So let's start a chapter with Bohr's model of an atom. So students, as you know, in our previous lectures we have studied Thomson model and Rutherford model, and because of the failures in those models, the third model, Bohr's model, came into existence. So we will see the postulates of Bohr's model and its applications, how it helps in various ways. So firstly we will study the postulates. The first postulate is electrons revolve around nucleus situated at the center. It's a very simple that the electron present in an atom revolves in a circular orbits situated around the nucleus, where nucleus is present at the center. Here in this picture we can see that the nucleus is present at center and our electron is revolving around it. The second one, electrons revolve in fixed energy shells known as orbits. Here you can see the path which electron is following is termed here as orbit. So these are the shells, these are the energy shells where electrons revolve, and these are called as orbits. The third one, only those orbits are possible which have fixed angular value of angular momentum. So we cannot say that every kind of orbit is possible. There is a condition that only those orbits are possible, or only those orbits exist which have fixed value of angular momentum. So angular momentum is mvr is equals to nh over 2 pi. Here n is the number of shells, h Planck's constant, pi euro mathematical pi, v is the velocity of the electron, m is mass, and r is the radius of that orbit in which the electron is revolving. So if the angular momentum will be positive or it will be any fixed value, only then that orbit will exist. So next postulates, shells are named as K, L, M and N. So as we have said that the electron revolves in fixed energy shells, and those energy shells are named alphabetically starting from K, where K is our first shell, and then later on L as a second, M as third, N as fourth, and so on. Here in this picture you can see that this is our nucleus, and after the nucleus the first shell, this one, this is termed as a K shell and is first one, N equals to 1. The after K, L shell, which is second one, then third M, and then fourth N, and so on. So the next postulate, different orbits have different energies. As long as electron revolves in a particular orbit, it will not release any energy. So what it means? It means that for example this is our electron, and if this is revolving in this K shell, till this electron will revolve in the K shell, it will not release any kind of energy. Here in this orbit this electron is having any fixed amount of energy, but this will not release any amount of energy. So the lowest energy orbit possible for electron is called its ground state. So in this case we can see that the after nucleus the first shell is termed as K shell, and this is the lowest orbit where an electron can revolve. So this K orbit or K shell is our ground state of this atom. So orbits other than the ground state are called excited states for that electron. So in this case we can see that this K is our ground state, and other than K means that L shell, M and N, these are the excited states for this electron, because this electron is present in K ground state. If this will move to higher state, that is to L, M and N, these states are excited states for this electron. अगर हम बात करें कि जो ये इलेक्ट्रॉन L शेल में प्रेजेंट है, तो इसके लिए जो L है वो इसका ग्राउंड स्टेट है, और M एंड N है वो एक्साइटेड स्टेट्स है, और जो K में प्रेजेंट है उसके लिए L वाला जो शेल है वो भी एक्साइटेड स्टेट है. So we can say that the electron is present in which orbital, that orbital is its ground state. Other than that, which are above that orbital, those are the excited states for that electron. So example, K is equals to ground state and L is our first excited state and M is our second excited state. So next one, electron can go from ground state to excited state by absorbing energy equal to difference of energies of two states. As in the previous slide, we have seen that the electron will revolve in a fixed path and will not release any kind of energy. And here we are saying that electron can go from ground state to excited state by absorbing energy equal to difference of two energies of two states. So for example, this is our first state, and if we denote it as K, this one is our K, this is L and this is M. So here we can see that if K has 10 unit energy, L has 22 units and M has 35 units of energy, then the energy difference between L and K will be the difference of energies of both the shells, means energy of L minus energy of K, that is 12 units. If the electron is present in this first K shell, then if it will release absorb 12 units of energy, then it can move from n equals to 1 to n equals to 2. And similarly, if we have to see for n equals to 1 to n equals to 3, it can be seen as difference of M minus K, and here it is 35 minus 10, that is 25 units, means if electron has to move from first one to third state, then it has to absorb 25 units of that energy. So the next postulate is electron is not stable in the excited state, so it returns to ground state by releasing energy equal to difference of two orbits in the form of EM waves. So अगर हम बात करें कि हम अगर जनरल एग्जांपल देखें कि कोई भी चीज़ है जो वो अपने घर में, यानी कि जो अपनी ग्राउंड स्टेट है उसमें सबसे ज़्यादा स्टेबल होती है, तो सिमिलर केस ही हमारे इलेक्ट्रॉन के लिए है कि अगर हमारा इलेक्ट्रॉन अपने ग्राउंड, जैसे अगर वो n1 से जंप करके n2 या n3 में चला भी जाता है, लेकिन इट विल बी अनस्टेबल इन n3 एंड n2 और वो एनर्जी रिलीज करेगा और वापस n1 में आएगा. सो जो एनर्जी वो रिलीज करेगा, एक तो वो एनर्जी EM वेव्स की फॉर्म में होगी एंड द अमाउंट ऑफ एनर्जी विल बी इक्वल टू डिफरेंस इन द एनर्जीज ऑफ बोथ द लेवल्स. मीन्स जैसा कि हमने देखा कि उसे एक्साइट होने के लिए कुछ अमाउंट ऑफ एनर्जी चाहिए जो वो एब्जॉर्ब करेगा. सिमिलरली अगर उसने एब्जॉर्ब करके जो हाई स्टेट में गया है वहाँ से वापस आना है तो सेम अमाउंट ऑफ एनर्जी उसको रिलीज भी करनी पड़ेगी एंड दैट एनर्जी विल बी रिलीज्ड इन द फॉर्म ऑफ EM waves. So these were the postulates of Bohr's model of atom, and this model is very important from the previous models which we have studied. So please do remember these postulates and study it carefully. Now the important point, Bohr's model is only for uni-electron species. Means the Bohr model cannot be applied for all types of species. It is only applicable for uni-electron species. So means uni-electron means the species which are having only one electron. So the question arises ki sir, what are those type of species? So here we can see that if we talk about the hydrogen atom, hydrogen has one proton and one electron, so it is uni-electron as it has one electron. So now helium has an atomic number of 2 and it has 2 electrons, but helium positive indicates that it has donated the one electron and now it is left with only one electron. So this is also a uni-electron species, and similarly lithium 2 positive is also a uni-electron species. So these type of species can show the properties or the points which are indicated by the Bohr's model. So next term is our excitation energy. So as we have said that the electron can move from lower orbit to higher orbit, and the amount of energy required to do such an excitation is called excitation energy. Energy required to excite an electron from lower shell to higher shell, as we have discussed that if we have to move the electron from n equals to 2 to n equals to 3, the energy required will be our excitation energy. So these were the postulates of Bohr's model. Now we will see the applications of Bohr's model. Means कि हमने मॉडल तो स्टडी कर लिया, उसने क्या क्या पोस्टुलेट्स बताए हमने वो भी देख लिए. नाउ उसकी एप्लीकेशंस क्या है, हमें उसका यूज क्या है. सो द फर्स्ट यूज इज वी कैन कैलकुलेट रेडियस ऑफ डिफरेंट शेल्स. मीन्स कि जो हमारा एटम है उसमें उसके अंदर हमने बोला अलग अलग शेल्स हैं के एल एम एंड एन. सो अगर हमें ये तो हमने एग्जांपल के लिए 4 शेल्स ही लिए, तो अगर आपको कोई बोले कि आप 20th शेल का रेडियस फाइंड कीजिए या आप 15th शेल का रेडियस फाइंड कीजिए, सो रैंडमली तो हम सोच भी नहीं सकते कि कैसे होगा क्योंकि हमें कोई आइडिया नहीं है. सो द फॉर्मूला गिवन बाय बोहर्स मॉडल फॉर फाइंडिंग द रेडियस ऑफ एनी शेल इज Rn, मीन्स रेडियस ऑफ दैट nth शेल, इक्वल्स टू 0.529 multiply n square by z, where n is the number of the shell and z is the atomic number of that atom of whose radius we are calculating. So here important point is that if we put both n and z as 1, means कि हमारा शेल भी फर्स्ट है और हमारा जो एटम है उसका एटॉमिक नंबर भी 1 है. सो हमारे जो रेडियस की वैल्यू है दैट विल बी 0.529 एंड एटॉमिक नंबर 1 तो हाइड्रोजन का होता है. इट मीन्स द रेडियस ऑफ द फर्स्ट शेल ऑफ हाइड्रोजन एटम इज 0.529 एंगस्ट्रॉम. सो दिस इज द फॉर्मूला टू कैलकुलेट रेडियस ऑफ डिफरेंट शेल्स. Next one is we can calculate velocity of electron in the nth shell. So हमने कहा कि इलेक्ट्रॉन है जो वो हर शेल में रिवॉल्व कर रहा है, तो वो किसी अगर आपको बोला जाए कि वो किसी nth शेल में रिवॉल्व कर रहा है एंड टेल मी द वेलोसिटी ऑफ इलेक्ट्रॉन इन दैट शेल, सो हाउ विल यू कैलकुलेट इट. सो दैट विल बी कैलकुलेटेड बाय द फॉर्मूला Vn, मीन्स वेलोसिटी इन द nth शेल इज इक्वल्स टू 2.18 multiplied by 10 raised to power 6 multiplied by z over n, where z is the atomic number and n is the number of the shell, and the units of velocity are meter per second. The third one, we can calculate energy of electron in a particular orbit. So now we have calculated the radius of the orbit, the velocity of electron in orbit. Now it's time to calculate the energy of electron in any particular orbit. So the energy is equals to minus 2.18 multiplied by 10 raised to power minus 18 multiplied by z square by n square joule per atom. Here it is written Vn, it's by mistake. Here it will be En, means energy in the nth shell, and this is the formula for that. The last one is calculation of excitation energy. Means as we have said that the energy required to excite an electron from lower shell to higher shell is called the excitation energy. So if we have to calculate the amount of that energy, it can be calculated using this formula: 2.18 multiplied by 10 raised to power minus 18 multiplied by z square into 1 over n1 square minus 1 over n2 square, where n1 and n2 are two different shells. मीन्स n1 और n2 हमारे वो शेल्स हैं जिनके बीच का हमने डिफरेंस कैलकुलेट करना है, एंड z सिमिलरली हमारा एटॉमिक नंबर है। सो दीज आर दी एप्लीकेशन एंड स्टूडेंट्स ये एप्लीकेशंस आपको बोर्ड पॉइंट ऑफ व्यू एज वेल एज फॉर कंपटीशन पॉइंट ऑफ व्यू दोनों ही पॉइंट से बहुत ही इंपॉर्टेंट हैं। इन फॉर्मूलाज के बेस्ड आपको कोई भी क्वेश्चन आ सकता है, वेदर आपके स्कूल एग्जाम्स में और आपके कंपटीशन यानी कि जेई और नीट के एग्जाम्स में भी आ सकता है। सो इसमें करना बिल्कुल सिंपल है, आपको जस्ट वैल्यूज सब्स्टिट्यूट करनी होती है, लेकिन जो मेन बात है इन्हें याद रखना कि कौन सा फॉर्मूला रेडियस के लिए है, कौन सा वेलोसिटी, कौन सा एनर्जी एंड कौन सा एक्साइटेशन एनर्जी के लिए है। सो और नेक्स्ट वन इज मोर एनर्जी यूनिट्स। सो जैसा कि हमने पिछली स्लाइड में स्टडी किया एनर्जी, तो वहाँ हमने एनर्जी का जो यूनिट स्टडी किया वो था जूल पर एटम। सो कई बार हमें एनर्जी डिफरेंट यूनिट्स में भी वो कैलकुलेट करने के लिए बोल देते हैं, जैसे कि किलो जूल पर मोल या फिर इलेक्ट्रॉन वोल्ट पर एटम। सो उनके लिए फॉर्मूला हमारा थोड़ा चेंज हो जाता है, दैट इज फॉर किलो जूल पर मोल E इज इक्वल्स टू -1312 मल्टीप्लाइड बाय Z स्क्वायर ओवर N स्क्वायर, and for electron volt per atom it is -13.6 multiplied by Z square over N square electron volt per atom, and 1 electron volt is equals to 1.6 multiplied by 10 raised to power -19. So students, this was our Bohr's model of atom, its applications, that how it is useful in daily problems or how the questions from this model can be asked to us. So I hope you have liked the video. So if you like the video, share it with your friends and subscribe to our channel. Thank you.